Hi students, welcome to my class. Today we are going to see composite materials, FRP, fiber reinforced plastic. So we know we have three kinds. In that way, today we are going to see about fiber reinforced plastic, right? Let us get into the class. FRP, fiber reinforced plastic. So it is made up of polymer matrix and reinforcing faces fiber, right? So fibers, what are the types of fibers used? It is glass, it can be carbon, it can be aramide, or it can be basalt. Rarely, certain other fibers like paper, wood, asbestos can also be used. Okay, the polymers are usually made up of matrix, epoxy, phenol, formaldehyde, or urea formaldehyde, or polyamides. Right. This FRP exhibit high strength, high specific strength and high stiffness. Okay. So why we want this composite material? We want to equal to the property of a steel or an iron, which has a higher strength. So we want to bring it to that level where polymer is a plastic material with a less strength. So this reinforcing phase increases the stiffness or the strength of the material. Okay, we'll see in detail in the same class. So use as a reinforcing phase in concrete, bridges deck, modular structures, farm works, etc. External reinforcement for strengthening and seismic upgrade. Seismic is earthquake, right? FRP are commonly used in many applications like aerospace. See, where we want less weight but good strength. Okay. Automotive, marine, construction industry, marine, corrosion resistant but strong enough. Right. They are commonly found in ballistic armor and cylinders for self-contained breathing apparatus. So lightweight, right? So that we can carry cylinders, which could be lightweight, so that we can carry. See, I have a separate video for applications of FRP alone because it is so interesting to know that uh, composite can find application in each and every nook and corner. So plastic, as a plastic, we never use it. Polymer, we never use it as a polymer itself. It is a reinforced material. Okay, we put some other material into it, reinforce it, make it as a composite, and then we are using it. So FRP, fiber reinforced plastic, the property of this is dependent on fiber, types of fiber which we are using, fiber concentration, how much amount of fiber we are in reinforcing it, okay, and distribution. It is whether it is in one directional or it is in multi-directional, whether it is continuous, discontinuous, all these things is distant. Based on these three factors, the property of the outcome composite will be different, right? So we may have a continuous FRP fibers, right? And which can be multi-directional. See, vertical it is also there, horizontally also it is kept. It can be viscous or chopped fibers, right? And also it can be particulate. Particulate means just like concrete. Gravels, we use it as particulate, right? So these are the phase which gives you strength to the polymers, right? What are the different types of fiber and plastics? Okay, so it can be continuous, it can be discontinuous. Okay, so continuous, you can have unidirectional. Okay, it will be stronger in one direction, in another direction it will be weaker. It can be bidirectional, so at any point or any part it will show same strength, right? So discontinuous, see here aligned one, and this is random. Okay, aligned one means in one directional it is stronger. Okay, it shows higher strength in one direction. Okay, in random, it shows equal strength in all direction, but strength will be less here. But here the strength will be more in aligned state, right? So and then we have FRP maybe intra-layer, right? So laminates you can have, you can see green one and gray one. So that is of different material, this is of different material. All these are reinforcing phase. So reinforcing phase need not be one material, it can be any number of material. Polymer matrix could be one. Okay, reinforcing phase could be many. See here, intra-layer. See here, it is broken. It's not single sheet. You have number of sheets, right? So which is arranged here. And we have inter-yarn. In between, we have fibers, right? This could also be there. So this is hybrid. So this could be made up of different materials. Need not be of same kinds of materials. Okay. Properties. High strength to weight ratio. So for less weight, it shows a very high strength, right? If you take polymer matrix, say epoxy, its strength will be less. But when you put reinforcing phase into it, so its strength is getting increased with the same weight. Okay. So strength is compared with iron. Iron is stronger, but at the same time, it is heavier, denser and heavier, right? But we don't want weight, but we want the strength of the iron. How to get it? So it is the composites. Okay. So we have corrosion resistance. Yes, obviously iron undergoes corrosion. Polymer does not undergo corrosion. Excellent durability and long performance. It shows excellent means if I say iron, to that extent, it is not excellent performance, but durability, I can say it will have a good life. Okay, because corrosion resistant it is, but polymer has its own strength and weakness. So that property is also included in it. In general, I can say excellent durability and long-term performance, high degree of design flexibility. Yes, this is one very important thing. See, if you have unidirectional FRP, then its design flexibility will be in only in one direction. It will not be in both the direction. Okay. And fiber, viscous, you have other particulates, no, that will allow any complex shape we can give structure to be easily fabricated. Actually, this composite has a restriction in structural thing. Okay. Depending upon the structure, we can go with different types of reinforcing. Okay. Electrical insulation, non-conductive in nature, polymer definitely is not a conductor, right? Exhibit excellent dimensional stability over a wide range of temperature and environmental conditions. So this composite material also prepared to work under a wide range of temperatures. It can work under a hot condition, it can work under a cold condition. So where wide range of environmental conditions, this composite material can be utilized. Fatigue resistance, that is break, right? So withstand repeated loading and unloading cycle without experiencing structural failure. See, if you use only fiber, okay, if you go for fatigue, so its resistance will be very low. But if you take only matrix, say epoxy, if you go for fatigue resistance, it will be very high. But when you combine these two, it will be moderate, and that is required. I want strength. I want both the property together, right? So both the opposite property together, then I have to go for a compromise of it. And you get a moderate strength or moderate fatigue resistance as well as other resistance also, right? Then resin reinforcing phase, right? Let us see. Resin is nothing but your matrix phase, right? This matrix phase, I take the pen. Transfer stress between reinforcing fiber and to protect from mechanical and environmental damages. So it takes the stress, it does not keep it with it, it gives the stress to the reinforcing phase. Okay. And it protects the reinforcing phase from the environmental damages, right? So the resin could be of type thermoset and thermoplast. So thermoset examples are given: polyester, vinyl ester, epoxy, phenolic, PU. Thermoplast examples are ABS, nylon, PE, PP, PET, reinforcing phase. So it provides strength and stiffness to the material in one direction. Okay, if you use particles and viscous, it will be in all directions, and other things in unidirectional. So this could be natural or man-made. Reinforcing substance could be natural or man-made. Example, aramide, boron, carbon, glass, nylon, polyester, and PE, PP, etc. Then we have, I'm not going to classify thermoset and thermoplast, a basic difference between these two. So thermal stability is very high. Thermoset, thermal stability is very high. Reduced creep and stress relaxation. So here it is brittle in nature. So, okay, so it has reduced creep and stress relaxation. Chemically resistance is highly chemically resistant. Excellent fiber orientation due to low viscosity. If you use this material as a reinforcing phase, then it has an excellent orientation due to low viscosity. What about thermoplast? It is a low temperature functional material, right? That is room temperature functional material. It is easily recyclable and reformable. That is, thermoset is not recyclable. Okay. Comparatively, cost is very low cost. But it working temperature is moderate. Here, working temperature is very high. Okay. See, composite, most important property is tensile strength, right? To understand this, we have a graph, stress versus strain graph. See, here we have fiber, which is brittle. Okay, so it takes up all stress at one point, and here at this point it breaks up. It is fatigue. Okay, here you have another material matrix, so it is never fatigue. It is mostly elastic. See how much amount of strain. Whatever stress you give, it nullifies the stress and take it as a strain here. Okay, so this does not have a strength at all. Okay, this matrix phase does not have a strength at all. It has a strength, but it is brittle. But I want both the properties. So if I mix these two together, I get a composite material, right? Which is having a good strength as well as the flexibility also, right? So if I add more amount of fiber, then I may have a graph, say like this. Okay. If I add less amount of fiber, more amount of matrix, I may have a property stress bar strain graph somewhere here. So more fiber, brittle, it goes towards brittleness, less fiber, it goes, maybe it will go like this. Okay. And will go like this. At this point, it may break, right? So it depends upon the concentration of the fiber, type of fiber which we have taken, but it gives the compromise of these two properties, right? Disadvantages of composite material, high manufacturing cost. See, when a product is coming out, we have to think about the cost also. Brittle, not ductile failure. Okay. Composite must be completely cleaned of all contaminants before repair. Composites have limited shelf life. They have to put into use immediately. They cannot be kept for longer time in shelves. To understand this composite still better, I've taken a table from this reference. You can see the reference here. From this reference, I've taken this material to understand better. See, material reinforcing phase is carbon aramide glass. Okay, epoxy is the matrix phase. Okay, see here it's tensile strength, how it is. Epoxy, what is the value? See, it's very less, right? Modulus of elasticity also, see here. Here it is very less. Okay, but when it comes to CFRP, that is carbon fiber reinforced polymer, that is epoxy, see it becomes moderate. The value is moderate. Okay, so both the property I am able to incorporate, elastic property as well as strength. Okay, if you have elastic property, it is less strength. But if you are having a good strength, it is brittle in nature. I want to break the brittleness, but I want to incorporate elasticity. See how the property is varying. Okay, see here modulus of elasticity. Property of it varies. So what is the value for CRP, CFRP? Okay. Thank you, students. Hope you understood the topic. Next video will be on the detailing on applications of FRP, each and every applications. It gives you tremendous view on applications. Let us see where and all this composite can find applications. Okay, thank you.